Algebra 1 Common Core, Unit 7, Section 1. So the previous couple of chapters, Units 5 and 6, were dedicated mostly to linear functions. That's where we had a slope, a y-intercept. At the end of 6, we started talking about inequalities, but there was still a slope and a y-intercept, and then you had, solid dotted and shading. But slope and y-intercept were very much present because they were still linear based. Well, now we're finally getting into some new functions. We're going to get talking about quadratic functions in this chapter, Unit 7. We have a couple other that we're going to talk about in other chapters, but 7 and 8, we're only just talking about quadratics. So what's the difference between a quadratic and a linear function? Well, the linear function, or lines, like you're familiar with, y equals mx plus b, or an example would be like y equals 2x plus 3. The key here was that we had a slope of 2, which is really 2 over 1, and a y-intercept of 3, and that's where we started on the y-axis. And so slope and y-intercept are really the big characteristics of linear equations. For quadratics, they look very different. Instead of mx plus b, we have ax squared plus bx plus c. So it's got 3 parts. Like a typical quadratic is like what you're seeing down here. I'll write it up here too. Y equals x squared plus 4x plus 3. Now that should actually look familiar because we did talk about stuff like that. We didn't graph them, but we did factor them. We called them trinomials. And the big thing that stands out, the difference between the linear and the quadratic, is the presence of that x squared variable. Like the linears have an x, but it's x to the first. Well, now we have x to the second, so it's called a degree 2 equation. And that's what makes it a quadratic, is that its highest exponent is 2, versus a linear where the highest exponent is 1. So we have factored these, and we are going to go back to factoring and talking about these, not in this video, but we are going to relate some of that factoring stuff we did to this and how we were solving equations with factoring and stuff like that. So that's going to come back because we were really working with quadratics at the time, which didn't really tell you. So anyways, these quadratic graphs, they look very different than linear graphs. Linear graphs are lines. They're just straight lines like that. A quadratic graph is a parabola. And you have that word over here. A parabola. Sometimes we call it a quadratic, but it's called a parabola graph, which is the graph of a quadratic, and it looks kind of like a U. So it's very different than just a straight line. It does not have a consistent slope really at any point because it's a curve. It's constantly changing, and then it kind of has a pattern. Now, as I mentioned, for lines, there was a slope and a y-intercept that were really, really important. When it comes to quadratics, we have things called roots and a vertex, which you're going to see down here, roots and vertex. Those are really the key characteristics of quadratic functions. So they're very different types of functions. So how do we graph a quadratic function? Well, for slope and y-intercept, you can kind of see it. For a quadratic, it's not quite that simple. You really want to have a table of values when you're graphing a quadratic. So the example here, it's asking us to graph the quadratic. This is the quadratic we're doing over the domain. Remember, domain is an important word for us. It talks about the x values, and so it's giving us a specific domain. So when we graph this, we're just going to graph it over the x-axis from, -5 to 1, and so your y-axis will be somewhere. But we're just looking for a parabola in this area type of thing. So because we could, go on in both directions to infinity, but we're giving you a specific domain, and we'll talk about why later on. So we have graphing calculators, which are great, and that's going to really make this a lot easier, and I'll show you how to do that. But if we didn't want to use our calculators, we could do it manually, old school, with a table. And so given a domain of -5 to 1, that means your x values are going to go from -5 to 1. And you just go up by 1. So -5, -4, -3, -2, -1, 0, and lastly 1. So start here and there. And then one at a time, you're just doing f of that, meaning you're replacing your x's with those input values. Like for -5, for example, we replace x squared with -5 squared. Instead of plus 4x, it's plus 4 times -5 plus 3. And the result was 8. And so we plugged in a -5, we got out an 8. Together they form a coordinate of -5, 8. And you continue that for all of these points, and you end up with all these values. And then you can plot them and graph all those points, and you end up with this. I mentioned before the quadratic graph has those important characteristics, a root and a vertex. And so what are those specifically? Well, the vertex is where the graph kind of changes direction. And so that would be down here. And it's also known as a turning point. We see that it's written up here that the vertex is also known as a turning point because it's kind of where the graph turns direction. Like see the graph is going down, 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 down. It stops, it turns around and goes up, up, up. You know, so that's what we mean by a turning point, and that's the vertex. And it's right smack in the middle of the graph. See, there's this symmetrical, symmetry, mirror image of itself. We're going to talk more about the symmetry in the next video, actually. But that's where the vertex is. It's the maximum if it's like this, or in this case, it'd be called a minimum because it's the lowest point. But it's where the graph kind of turns around and comes back. The roots have to do with x-intercept points. Remember, for linear equations, y-intercept was really important. Well, for all of the other functions, the x-intercept, where it hits the x-axis, is more important. So these 2 points here, in this case, are what are called roots. It's where the graph intersects the x-axis. And so we can actually figure these values out just by looking at the table. You don't even need the picture. Because what do you know about roots? If roots are on the x-axis, that means their y values have to be 0. So any coordinate you see that has a y value of 0, like here and here, those are roots. Because that means if it has a y value of 0, it's sitting on the x-axis. And right smack in the middle of those is going to always be the vertex. There might be points in between the roots and the vertex, but the vertex is always halfway between the roots. And not only that, you can look at the pattern. See what's happening here, especially look at the y values. Notice it goes 8, 3, 0, negative 1, 0, 3, 8. So it's starting at 8 and then it's decreasing down to negative 1 and then it stops decreasing, it turns around and starts going back up. But not only that, notice the symmetry. Like we have 8, we have 3, we have 0. Like they're all repeated twice because there's a symmetry to these graphs. But negative 1 isn't repeated because that's smack in the middle. That's where it turns around. That's your vertex. So let's try graphing one of these from scratch. Next page. So for the quadratic function given below, we want to determine a set of coordinates, state the vertex, state the roots. We're given a domain here. The domain is negative 2 to 4, so we're really working from like here to here. So our whole picture is going to be kind of contained in this little domain here. So how can we do this? Well, if we didn't have a calculator, what we would have to do is using our domain, we'd have to do our negative 2, negative 1, 0, 1, 2, 3, and 4, and then one at a time plug them in here. And that's not too bad, but it's a little tedious, but luckily we have graphing calculators that allow us to kind of have a shortcut. Now I don't have the TI calculator on here, so I'm going to use a website called Desmos, which is a great website. It's a free website. You can check it out, desmos.com. And they have a free graphing calculator utility. And so what I did was I typed in this function that we're working with here. It was x squared minus 2x minus 3. So I put that into, oops, that's the wrong one. I put that into Desmos here, x squared minus 2x minus 3, and it gave me this table. So I specifically, typed in this domain. You have to tweak it a little bit to get this table to pop up. You got to get used to the program a little bit here and there. But that's, so these are my table values. When I plug in negative 2 into this, I get 5. When I plug in negative 1, I got 0. And you can see that because negative 1 squared would be positive 1. Negative 2 times negative 1 would be positive 2. So it's really 1 plus 2, which is 3, minus 3 is 0. So that's why that's going to be 0. Same thing with positive 3 here. You plug in 3 squared is 9. It's like 9, and then minus 6, minus 3, you get 0. So that's all these values just come from plugging them in one at a time. But let's see. Let me see. I want to take this table over here. So negative 2, 5, negative 1, 0. So it was negative 2. Let me get back to a pen here. So negative 2, 5, negative 1, 0. I can see this here. Negative 3, negative 4, and then the pattern repeats. So this was negative 3. This was negative 4. And then back to another negative 3. And then again, notice a couple of things about the patterns here. That because this went 5, 0, negative 3, negative 4, and then it went back to negative 3, that's going to be my vertex, because that's where it changed direction, started going back. before negative 3 was 0, so after negative 3 is going to be 0, and then next was a 5. So you see that same 5, 0, negative 3, 5, 0, negative 3. Where I see the y values of 0, that's a root, and that's a root. So like I said, with the graphing calculator, for you guys, you're going to want to type this in your y equals portion of your TI calculators. And then you're going to want to hit second graph. So the second button, then the graph button. And that pulls up the table for you. If you hit the graph button itself, you're going to get this, the picture of the graph. But hitting second graph on your calculators pulls up your table. And you might have to move your table up and down a little bit to find the x values you need here, but you'll see this pattern pop up, and that's how you know you're kind of in the right spot too. So if we plot these points, negative 2, so x value of negative 2, a y value of 5, right? Remember when you're plotting coordinates, it's not like slope. Sometimes people do this in reverse because slope is, rise over run, up and over. But when we're stating coordinates, it's side to side first. X is side to side, and then y is up and down. So negative 2 is left 2, positive 5 is up 5. Negative 1, 0, 0, negative 3, 1, negative 4. And then even at this point, once I know this is the vertex, I don't even need to look at my table anymore. I just know that I'm going to see that mirror image. So it's going to be the same point over here, up over matching this other blue point. X1 over is going to match this blue point, but it is 4, 5, and 3, 0, and 2, negative 3, and so on. When you're drawing your parabolas, it's a little bit harder than drawing a line because you can't just put a ruler there and trace it. I suggest going from your vertex out in one direction, throw an arrow, go back to the vertex, and go out again, draw your arrow, and go slow. Because if you go too fast, you're going to miss points. And if you try to do it all in one shot, you're going to miss points. And so you have to be very careful with it. And that's it. That's graphing your quadratic. Again, we could label that this is our vertex. It's where it all turns around. And these are the roots. Notice that the roots weren't right next to the vertex is still in the middle of the roots, but there can be points in between. Sometimes people think the 2 points next to the vertex are the roots. It was in the example on the previous page, but it's not here. And that's really about it. With the graphing utility, it makes getting this table really easy and then just recognizing the features of it. There's another example down here, and I'll show you what this looks like in Desmos, but I'm not going to take the time to graph it. You could graph it on your own if you want. But negative 2x squared minus 4x. Now we're going to talk about transformations in a couple of videos where what happens when I put a negative number in front of the parabola. Well, actually what happens is instead of looking like a U, it gets flipped upside down. It looks like an N. But let me show you in Desmos what that looks like. So negative 2x squared minus 4x, and then we'll cut this video off. So if we change this to a, let's see, a negative 2x squared, and I want to delete some of this, negative 2x squared, and was it plus 4x or minus 4x? Minus 4x. So change this now to a minus 4. And then you can see that our parabola is upside down because of that negative in front of the x squared. It's also a little bit more narrower, and we're going to talk about that too. But even in this program now, if I wanted to, I could change my domain from negative 3 to 1, and so I could change this to be a negative 3, and then change these values to correspond to what I need them to correspond to. So let's see, let's say negative 2 followed by I was curious if that would just do it for me, but no. So 1, and then not 1, we want to do negative 1 there. Oops, sorry. Negative 1, then you could do 0, and you could play with this program. Like I said, it's not quite as good as your calculators. Your calculators can just give it to you all in one shot, but this is a nice if you leave your calculator in school or something like that. All right, so that is it for graphing quadratics, and we're going to be talking about these functions for a while. See ya.